This is Abdurrahman Adam. I'm solving problem number 34.66 on Mastering Physics. A 2 centimeter tall candle flame is 2.2 meters from a wall. You happen to have a lens with a focal length of 29 centimeters. How many places can you put the lens to form a well-focused image of the candle flame on the wall? For each location, what is the height of the image, and what is the orientation of the images? I've went ahead and drawn the picture to get a better idea, as well as the knowns. We know that the total distance is d. I chose it, so it'll be 2.2 meters, which is 220 centimeters. We know the height of the candle is 2 centimeters, and we know the focal length is 29 centimeters. I've illustrated the focal length here. Uh, the first step we want to do is kind of notice that the relationship between d and s. So d is equal to s prime plus s. So the d is the total distance, is the sum of the image distance and the object distance. We can rewrite this equation to be the image distance is the total distance minus the object distance. We can use the equation for the image distance. 1 over s prime is equal to negative 1 over s plus 1 over f. And since we know the focal length but not the image distance or the object distance, we can put that on one side. We get 1 over s prime plus 1 over s. We substitute for s prime d minus s. We get 1 over d minus s is plus 1 over s is equal to 1 over f. At this point, you can multiply this by d minus s over d minus s, and you multiply this by s over s, you get s plus d minus s over s times d minus s is equal to 1 over f. You can simplify it. It becomes 1 over f is equal to d over ds minus s squared. So cross multiplying, you get df is equal to ds minus s squared. Simplifying further, you get negative s squared plus ds is equal to df. We can also choose to subtract both sides by df, and you get this. Let's substitute what we do know, d and f. We get negative s squared plus 220 s minus 220 times 29 is equals 0. We end up with the quadratic equation negative s squared plus 220s minus 6,380 is equal to 0. If we use a quadratic formula, we'll find two values of s. S is equal to 185.63 centimeters. S is also equal to 34.37 centimeters. Over here would be a good point to check to see the sum of s. So if s is equal to, since we know that the sum of both the image distance and the object distance is equal to d, and d minus s is equal to s prime, if s is equal to 185 plus 0.63, then s prime has to be equal to 34.37, and vice versa. Another way to think about this is both of these should add up to become 220 centimeters, which is d, the total distance. So now we see that we have 2 points. We can go back and answer this. Looking further, we can see that the ratio between s prime and s is equal to the ratio of the h prime and h, which is the image height and the object height. We know s prime, if we choose it to be 185.63 centimeters, that means that s has to be 34.37 centimeters. And we don't know h prime, but we do know h, which is 2 centimeters. Multiplying both sides by 2, you should get 10.8 centimeters. h prime is equal to 10.8 centimeters. And conversely, if s prime is 34.37 centimeters and s is 185.63, multiplying by 2 centimeters again, you should get h prime is equal to 0.37 centimeters. So over here, you should get 10.8, which rounds up to become 11, and 0.37 centimeters. Now, the orientation of both images. We can tell the orientation by the magnification equation, which is negative s prime over s. And if the magnification is negative, then the image is inverted. And since both of our image distances and our image distance and our object distance are positive, that means magnification has to be negative, so both images are inverted. Another way to assess this is that we've already assessed so far that this should add up to become 220 centimeters, and the image should be inverted, should be upside down, because its magnification is negative.